Welcome to Cisco TechBeat, the podcast that explores the people and stories behind what inspires the newest innovation. I'm your host, AB, and today I am welcoming Ramana Kompella, Cisco Fellow and Head of Cisco Research. Ramana leads a team of world-class researchers to conduct research in areas of strategic interest to Cisco, such as networking, distributed systems, cybersecurity, AI/ML, and quantum. Ramana, welcome to TechBeat.
Thank you, AB, for having me here.
My pleasure, my pleasure. And I want to jump right into quantum technology because Cisco is really focusing on quantum networking as a next generation technology. So what inspired this focus and how does it align with Cisco's broader goals?
Thanks for that question, AB. And, maybe I'll walk you through a little bit of timeline about how, quantum research came about. To give you a little bit of history, 2020 is when I joined in my current role as head of Cisco Research. And in 2020, quantum was still out. There's a niche community around quantum, but it's not as mainstream as it is today. And but I realized this is something that, as one of the charters for Cisco Research, is to really look at far out technologies where Cisco needs to be at. And so quantum was definitely on my radar, and I started pitching some ideas to my boss, Bijoy Pandey, who leads the emerging tech and incubation group, currently rebranded as Outshift. And together we thought, we need to start a small research investment around quantum, what it means for Cisco, and we need to figure this out. And quantum is going to happen at some point in time, so we just need to be ready, especially in the Cisco research realm. And our inspiration was very clear, right? So, Cisco has been the leader of networking and security of the classical internet and classical world for the past 40 plus years now, right? So we laid the foundations for pretty much all networking and security technologies that are in use today. And quantum is fundamentally different from how classical communication and classical, computing works. So we really thought, we need to put Cisco as the leader for quantum networking and quantum security. That's really the inspiration. We had no idea what it meant. And, part of the whole discovery over the past four years was really trying to figure out how quantum networking is different and how it is that we can actually enable the technologies that put Cisco on the map as far as quantum networking leadership goes. If you look at the past few years to even a decade, right? So IBM, Google, Microsoft, they all have invested a fair bit of money and built teams of hundreds of people to build out the next big quantum computer, right?
Right.
And usually the power of a quantum computer is measured in typically the number of qubits. The current state of the art is around 100 qubits, and that's that's really the state of the art today. Even the most aggressive quantum computers, the roadmap that these guys have laid out, they're talking about maybe 1,000 qubits machines that operate with 1,000 qubits by 2030 or so. Okay. For most practical quantum computing applications, you need millions of qubits. So there is a gap of about 1,000. And, Cisco comes in and, we talk about a quantum network that can really get us that 100x, 1,000x boost in quantum computing capacity. And suddenly, practical quantum computing is not as far as you think, because with the help of a network, you can take these, relatively smallish quantum computers, build an interconnect, and connect them up to offer multiples of millions of qubits in utilizable quantum power, right? So that's actually fantastic, and that pulls the timeline substantially towards practical quantum computing. And when we talk about this with analysts and all around the world, they got so excited because they only have seen the quantum computing narrative. And suddenly, Cisco enters with this quantum networking narrative, and the fact that practical quantum computing is not that far out is just ignited a lot of these analysts and press, and they got really excited. While we continue our journey on making quantum computing and distributed quantum computing with quantum data centers and quantum networks reality, we have a lot of classical applications that we can drive with quantum networks. So which means we have a really interesting pathway to showcase our technology and vision, and even have a real applications and real impact in the short term. So that's very interesting for us.
So that really exciting, and lots of opportunities and possibilities as you explore this technology. I don't know a lot about the technology, but from what I have read, it sounds like when it comes to building something like a quantum internet, for example, there are basically three things that are needed: research, simulation, and hardware. Could you kind of take us through, quickly each of those processes so we can understand what that means and how they work together?
Oh, absolutely. So, I think quantum internet and, quantum networks or quantum networking of the future really requires us to, first have a clear idea of, what it is that we are trying to build, right? What components do we need to bring together? And that means, things like, quantum switches, quantum network interface cards. And quantum networking actually broadly is very different from classical networking, in that quantum networking is, in classical world, what you do is when you want to send, a few bits from one host to another host, say Alice and Bob, Alice literally, takes those bits of information like zeros and ones, puts it in a packet, and this packet actually journeys through, several switches and routers and eventually reaches Bob. Okay. And that's the way it works. In quantum world, you don't quite do it that way. In the quantum world, you generate what are known as entanglement pairs. So entangled photons, if you will. So what that means is really two photons are really in an entangled state, which means something happens to photon one immediately happens to photon two, no matter the distance. And this is what Einstein used to call spooky action at a distance. So entanglement really is the foundation for for quantum networking. So from a research perspective, we really had to understand how quantum entanglement works, how we can actually incorporate that into building our quantum networks of the future. Um, and from because a lot of technologies are not really mature enough, we have to rely on simulation as a mechanism to really behaviorally validate how things will operate, right? Before the real hardware is available for us to use.
Right.
And sort of, all these three, right? You mentioned research, you mentioned simulation, you mentioned hardware development. They all operate, in tandem with each other, right? Simulation tells us, hey, you know what, something is feasible. And, we have some theoretical model that sort of like you can simulate quickly and figure out whether, this will work for the types of applications we care about. And if it does, then we actually go and prototype the hardware. And then once you actually develop your hardware, you realize, well, my simulation doesn't quite match my hardware. So I have to
Right.
enhance my model and and then simulate better and so on and so forth. So all these three actually are intertwined with each other. So for us to take something as interesting and complicated as entanglement, we really need to understand what it is, how our existing optical fiber infrastructure and optical switches and stuff that already we have developed for the classical world work with these entangled photons. Do they distort them? Do they distort their properties? And it turns out actually classical switches are not going to be good enough for quantum. And for quantum, we really need high fidelity, switches that maintain and preserve these entanglement properties as these photons are journeying through these switches. So, in other words, so a combination of all of these three are extremely important for us to be able to really advance the science around how to build these quantum networks of the future.
Absolutely. And I'm glad you described what entanglement is. And even though it's a much deeper than that, it sounds like you really need something with great capabilities to sort of handle this entanglement. And so this is a good segue to something that we at Cisco just created, which is the quantum networking entanglement chip. So I'm assuming that that chip is now allowing for better or more efficient communication and networking. What does the chip allow us to do that we couldn't do before?
Absolutely. Entanglement is the key idea here. And you need to be able to generate these entangled photons in order to be able to transfer one quantum information, right? One bit of quantum information, as they call it, qubits,
Mhm.
right? Instead of classical bits. So you need one entangled photon pair to be able to transfer one qubit of information. Okay. So in other words, you generate these two photons, you send one photon to Alice and one to Bob. If Alice wants to talk to Bob,
Sure.
and then you put the quantum information at Alice and that magically appears at Bob. Okay, Bob's location. So that's actually the teleportation part of it. There's the entanglement distribution, and then there is a teleportation. The analogy that we like to use is like, entangled photons are like these Amazon boxes that I ship one box to you and I ship one box to, whoever you want to communicate. I'm the entanglement source. And then if you want to transfer some information, you put some green flag in your box, which magically appears at the other end, right?
Right.
And that's the teleportation phenomenon.
Right.
And so the bottom line is the rate at which you can communicate quantum information is directly proportional to the rate at which entangled photons can be generated. So the higher the rate of entangled photon generation, we can build higher rate quantum networks using higher rate quantum entanglement generation chip. So the chip that we have generates upwards of 200 million entangled photons per second, equivalent to 200 mega qubits per second.
Wow.
Okay, that's the amount, that's the capacity. No, that's just the start of it. I think we are going to blow through the, giga qubit barrier pretty soon, in my opinion.
Wow.
So now our chip actually not only generates these entanglements, right? So, it also generates it with very high fidelity. What I mean by that is out of 100 entangled photons that it generates, more than 99 of them are actually entangled. So you know, less than 1% of them are defects, if you will.
Right.
Okay. And also, interestingly enough, this is compatible with existing fiber technology, which we have, like, pretty much the whole of internet runs on existing, the DWDM fiber technology. So it's actually compatible with that. And on top of that, when you talk quantum, you often imagine these gigantic cryo fridges with extremely low temperatures and stuff like that, right? Very
Yeah.
sophisticated.
Yeah.
This chip operates at room temperature. That's fantastic because you can actually really reliably deploy it across without requiring gigantic fridges to cool it.
Sure.
And in addition, it actually consumes very low power. It takes less than the amount of power it takes to fire up a pixel on your video, for example. So less than 1 milliwatt. So
Wow.
that's fantastic, along all these dimensions, and we are really, really excited about this.
That's amazing. That's amazing. I mean, I don't know the technology, but just the numbers that you're presenting sound so incredible that I imagine it's a huge step forward for us in terms of technology. Stepping back a bit, you'd mentioned sort of the whole quantum movement and the Outshift team, which is really the umbrella under which a lot of this is being done. And I know just from having had conversations with others on your team, there's really, within that team, there's really a mission to driving emerging technologies and solutions and resources for whatever we need for tomorrow. So I guess beyond quantum networking, although this will probably tie back into quantum, what other technologies in general is Outshift working on? And then how do those complement some of the quantum advancements, if they do?
Great question, right? So number one is, while quantum networking is critical, we are also looking at, post-quantum crypto. As you and many of your audience will probably know, that NIST has actually standardized post-quantum crypto last year in August. So these are essentially crypto technologies that are resistant to the emergence of a quantum computer breaking your classical cryptography.
Mm-hmm.
And so at Cisco, I mean, we are big into security. So we really are looking at how we can enable our customers, especially in the Outshift arena, how we can enable our customers to have observability around how much post quantum crypto has been leveraged in your particular enterprise, and that requires visibility into pretty much your data connections that are happening between hosts, and figuring out whether they're using safe crypto libraries that are quantum resistant or not. Okay,
Right.
so that's one piece that is related to quantum and quantum networking, but not quite, right? It's actually more around how we can secure our classical infrastructure, worrying about the emergence of quantum computing of the future, right? So
Right.
that's number one. Of course, outside of quantum, AI is big, right? So AI is actually is one of the most profound transformational technologies that we have seen in the past, I don't know, 10+ years now.
Right.
um, it's like emergence of cloud, emergence of mobile computing, and now the AI wave is actually equally, if not bigger, and definitely will have a transformative impact on pretty much every application, every job, every sector of our world, right? So, and Outshift, is really trying to build that internet of agents, as you call it. So agentic AI, which is really about leveraging AI to simplify certain types of human tasks, right?
Hmm.
And in a semi-autonomous to even more autonomous ways, right? So there is the assistants, then there is agents, and really Outshift is trying to enable this internet of agents by building an open and interoperable framework for agents to come together and solve critical tasks. That's a very big area of work for Outshift, and recently we've launched this agency, and agency is a common collective of several different companies coming together and adopting these open standards, so that agents developed by any enterprise or company can interface with another agent, and also be discovered in order to
Mm.
actually really solve complex problems, right? So, and it's interesting. I mean, post Chat GPT, of course, people really understood the power of AI, and everybody's talking about AI. But at Cisco Research, we've been actually working on large language model technologies for even before the emergence of Chat GPT.
Mm.
We've been actually publishing papers and really pushing the field in top tier conferences. I mean, over the past, I don't know, 3-4 years, we have had 40 plus publications in top tier conferences, such as this conference called NeurIPS, where Google published actually the first paper on what are known as transformers.
Mm.
This technology is really what is behind large language models in 2017. So at these kinds of venues, we've been publishing state of the art research, and we've been at this game for a while.
Absolutely.
Another transformational tech area where we are really getting excited about is embodied AI, right? Robotics. And of course, Jensen Huang at Nvidia mentioned, he's betting big on robotics, and so we've actually also started looking at robotics quite a bit. This is broadly the field known as embodied AI, where
Hmm.
agentic AI will also intersect with either purpose driven robots or general purpose robots, right? Like humanoid robots that can solve some tasks for you, like clean up the mess in your kitchen, for example.
Close the
The kinds
fridge
of
door.
stuff that you don't want to do.
Yeah.
Or clean some dishes or load up the dishwasher or what have
Right.
you, right?
Right.
So yeah, and what it entails to enable this technology in a safe manner, in a easy to um, easy to communicate and easy to train these different robots to perform various tasks that you care about, right? So these are all very interesting technologies that are around the horizon. They're not yet there,
Right.
but they are going to be there 2-3 years out. So we are actually conducting research in this space, and we have a robotic test bed in Chicago where we are working with some gripper robots to move objects, and
Yep.
we can communicate with it and give it tasks, and it understands what we're talking about, and does
Yeah.
does a few things. So fun stuff,
Yeah,
extremely fun
fun
stuff.
stuff. Definitely fun stuff, especially if you have your hands in it. I think it's also a testament to the fact that because we've been working on these things over time, it's not like we're just learning about the current technology X bandwagon and trying to hop on it. It's really, hey, we've been preparing for this. Now that it has become something that's more ubiquitous, we can kind of really dive in and kind of help lead the way in terms of advancements and innovations. So that's really cool. I'm going to actually take you back to another lifetime of yours when you were not here at Cisco, because I learned recently that you were a tenured professor at Purdue, and you were researching in the areas of networking and computer systems. How that sounds incredibly exciting. How did that experience as a tenured professor shape how you approach the role you have now, in terms of leadership and just what you do from day to day?
Oh, great question, AB. I feel like my academic career really helped me where I got to. I
Mm-hmm.
think in a way, because I mean, if you look at like a professor at a university, it's almost like a small startup, if you will. You as a professor, you need to identify problems that are obviously worthwhile to solve. Then you have to get funding from agencies, just like you go to
Always
VCs
funding.
to then you recruit students to sort of carry out your vision. You write papers and software to actually showcase your publications and make it available for broader consumption. Your customers really are like your peers who buy, whether you have a sound idea or you've done great or something like that, right? So
Right.
they buy your ideas and your research in a way. It gave me a lot of foundation for how to venture into areas which are uncharted, really pushing the envelope, which is really what we are doing at Cisco Research, right? So, and on top of that, sometimes academics get too far out and too away from what really matters. So oftentimes they're good at imagining sometimes very interesting problem spaces, but they may or may not be as real and as relevant.
Uh-huh.
So my world at Cisco Research actually has to marry with this ability to go out there into uncharted waters, but also keep it real and keep it closer to where the industry wants to head towards.
Right.
Right. So that's actually the grounding that I get from industry and being at Cisco, while allowing me to explore areas which are not as well thought out and not as well charted as before. Now, I also, I was at Cisco. This is my almost like ninth year at Cisco. This is my
Mm.
second stint at Cisco. My first
Okay.
stint at Cisco was I was part of a startup within Cisco. It used to be called Alpha Projects, and where we built, and I was the head of engineering for that, and part of the founding team of that Alpha project, where we built this product called the Network Assurance Engine for data center network verification and making sure that your data center networks are operating the way that you intend them to.
Yeah.
Okay, so in a kind of like realizing the vision of what we used to call self-driving networks, right? So really trying to figure out if something is wrong, why it went wrong, and if things are going astray, why they're happening, and reason it out and quickly put them back on track. That kind of vision was what was exciting about Network Assurance Engine. So the fact that I have product experience being at Cisco for a reasonably long time, in addition to my research experience, right, really came together in my role. I also leverage my academic expertise and experience. I mean, to work with faculty members. So Cisco Research is not just a mighty small team, but we also augment and fund research in many different universities. So being I can empathize with folks on the other end a lot better. I can understand what their motives are and what their strengths are and interface with them very, very well,
Sure.
which actually was very good for us to be able to secure almost 15 master research agreements with top universities like Georgia Tech and other places. We funded more than 300 plus projects with lots and lots of faculty members, advancing science and advancing technology, right? And
Yeah.
and and I think a little bit of my academic background plus the fact that I'm at Cisco and I think really helped establish this kind of a world class research organization such as Cisco Research. So.
Absolutely, and it feels good to bring it back around full circle because having gone through the university system yourself, you understand the value that these kinds of programs have on their students, and so it must feel really good. I'm gonna jump away from work completely now, and typically I try to end these conversations with just a look into my guest's life outside of work. Whenever you're not working, I know you're working a lot, and I'm going to actually preempt the question because I noticed that there's a guitar in the background and you happen to be sitting in a gaming chair. But the question normally is, what do you do when you're not working to, unwind and kind of just decompress? If there is anything related to either the guitar or the chair, that would be great, but it doesn't have to be that. Tell me what you do when you're looking to kind of find your zen space.
Yeah, so I think most of my time goes in work and outside of work. My family, my wife and three kids really offer me all the love and happiness to unplug. After a hard day's work. But
Yep.
me and my wife, we both love traveling a lot, so we like to take small vacations here and there, and go out in the woods, and we like hiking and chasing experiences and stuff like that. So that actually is fun. I also like cooking a lot. So my most recent remodeling, I made sure I get six burners and a chef's kitchen kind of set up where
Yes,
I
that's a
can
must.
experiment and subject my kids to my interesting makings, if you will.
Yeah, kids are good, great guinea pigs. I love cooking too, and hiking, by the way. So it's nice when you try a new dish, or you kind of revisit a dish that you're trying to improve, and you have
Exactly.
these built-in guinea pigs who either eat that or they that's what you've got for dinner tonight. So please, hopefully you like it. That's great.
Exactly.
Love that.
Exactly.
Love that. Well, that's a fantastic way to bring our conversation to a close. Ramana, thank you so much for your time, for all your thought leadership, and giving us a little bit of insight into your life outside work. And I might see you at Cisco Live, so hopefully we get to see each other in person. It'd be great.
Oh, absolutely. Would love to meet you in person. I will be at Cisco Live. We're going to
Excellent.
talk a lot about quantum in Cisco Live. So.
I'll actually understand it even more thoroughly at that point. So hopefully I can actually keep up. But thank you so much. And I look forward to us connecting again soon.
Oh, thanks for having me, AB. It's been a pleasure talking to you.
Likewise. Take care.